Got a good one for you today. Factor trees. One of my favorite things to do. Very useful. You just don't know it yet. All right, let's begin. So, factor trees, let's start with the word factor. What is a factor? Well, a factor is two things that are being multiplied together. So, if we do 2 times 3 equals 6, 2 and 3 are the factors, 6 is called the product. If we do, I don't know, give me two numbers. 7 and 5, Tanner might say, because he always says 7 and 5. Well, let's try it. 5 times 7 equals 35. 5 and 7 are the factors. 37 is the product. Okay, so factors are just any two numbers multiplied together, and normally when we say factors, we mean whole integer numbers, meaning there's no decimals, there's no fractions. Technically, so factors can technically be fractions and decimals too, but for our purposes, we're just going to think of them as whole integer numbers. Now, not all integer numbers are the same. There are numbers like 6 and 35 and 10. All these numbers, you can get two numbers to multiply together. 2 times 6, or 2 times 3 equals 6. 2 times 5 is 10. 5 times 7 is 35. And there's others, like 12 is a famous example, so famous, and 18. 12 you can get by doing 1 times 12, and also you can do anything times 1 to get it as well. 1 times 6, 1 times 35, 1 times 10. Now, but there's things like 12, we have 1 times 12, we have 2 times 6, we have 3 times 4, so there's multiple. 18 has 1 times 18, 2 times 9, 3 times 6. We got things like 48. We got 1 times 48, 2 times 24, 3 times something. 16? No, maybe. 16. 4 times 12, 6 times something. 8. Yeah, so there's a lot. So we got some factors that only have a couple pairings. We have some numbers that have a couple pairings of factors. We have some that have more, and we have some that only have one in itself. Now those special numbers are called prime numbers. So let me just list the first few for you. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. You impressed that I know so many off the top of my head? All these numbers, the only way to multiply to get them is by one in itself, and that's what makes them special. These are called prime numbers, and they are very useful in many things, but we're going to show you how we use them in factor trees. Now, what is a factor tree? Dang it, I thought I cleared all these frames. What's that doing there? Okay, it's gone now. All right, factor trees. So take this 48, for example. See how there's 1, 2, 3, 4, 5 different ways of writing to multiply it? Or let's start with 12 even. There's 1, 2, 3. There's 12. I drew 4 lines, but I meant 3, okay? All right, 12. What we want to do is just figure out one way to write it that encapsulates all the different ways to multiply. And we use this using prime numbers in factor trees. So what a factor tree is we just get a number and we draw 2 lines and we say what 2 numbers multiply to get 12. Like we already saw, there's like 3 options, but let's just choose one. Let's choose 3 times 4. Okay, that's great. We got 3 times 4. Now let's do it makes it a tree because now we're making more branches. What 2 things multiply to get 3? Well, 1 and 3, because we know that 3 is prime. But 4, however, how can we multiply to get 4? We can multiply 2 times 2. Look at that. We got a little branches sprouting. 2, can it be broken down into anything? No, it's one of our primes. 2 times 1 is 2, and that's all we got. So look, we got 3, 2, 2. So 12, if you think about it, is the same as 2 times 2 times 3. Okay, so this is called the prime factorization because all the factors we're left with, because they're all being multiplied, they're all prime. And 2 times 2 times 3 gives us 12. All right, let's do 12 again, but instead of doing 3 times 4, let's do 2 times 6. 2 times 6. Can 2 break down? No, we learned it's one of our primes, so we can circle it because it's done. How about 6? We can get 6 by doing 2 times 3. 2 we can't break down anymore, let's circle it. 3 can't break down anymore, let's circle it. What are we left with? We're left with 2 times 2 times 3. Look at that. So prime, these are all primes, they are prime factors, give us 12. So no matter how we do our tree, so see we started off with the 3 times 4 way and the 2 times 6, no matter how we did it, we just got left with the same result, 2 times 2 times 3, and that's just a unique way of writing the numbers we're working with. And they, as we'll see later, in a not factorization, least common multiple or greatest common factor video I'm going to be making, we can use prime numbers, prime factorization for that, and we can also use it when we're canceling out fractions. For example, let's say we have well, I'll do one more before I show you. Okay, let's do 48 since it's a little bit bigger. 48, 48, 48. We'll do 3 different ways. So 1 is 2 times 24. 1 is 3 times 16. And 1 is 4 times 12. So 2 is already prime, so we'll circle it. 24, there's multiple ways we can do it. Let's just do 6 times 4, 6 times 4. 6 can be broken down into 2 times 3. Those are both prime. 2 can be broken down 2 times 2. Those are both prime. What are we left with? 2 times 2 times 2 times 2 times 3. Okay. 3, we can't break it down. It's already prime. 16 can be broken down into 4 times 4. 4 times 4 is 2 times 2, or 4 is 2 times 2. 4 is 2 times 2. Those are all prime. We'll circle it. What are we left with? 2 times 2 times 2 times 2 times 3. And then over here, 4 times 4. 4 equals 2 times 2. 12. We already saw how to break that down. 3, we'll do 4, 2, 2, circle, circle, circle. And once again, we're left with 2 times 2 times 2 times 2 times 3. Now, if the numbers keep getting bigger, this could be kind of a long way of writing it. But what's our trick for simplifying? What's another way of writing 2 multiplied by itself 4 times? Exponents. 2 multiplied by itself 4 times, times 3. 2 multiplied by itself 4 times, times 3. 2 multiplied by itself 4 times, times 3. So this is called 2 to the power of 4 times 3. That's the prime factorization of 48. We just writing it as prime numbers. Now, yeah, it has a lot more uses than you realize now. You just need to know how to do it because it comes in handy. Now, let's see how we can use it in this case. So, let's say we have 12 and 18 as a fraction. Okay. Now, we want to be able to cancel the factors they have in common, right? So 12 is the same as, like we already learned, it's 2 times 2 times 3. What about 18? We haven't done that one yet, but I'll go ahead and tell you it's 2 times 3 times 3. Okay? So when we have these fractions, we can cancel them depending on which factors they have in common. They both have a 2 in common. They both have a 3 in common. What are we left with? 2 over 3. 12 over 18 is the same as 2 over 3. And if you look at it, what factor do they both have in common? They both have a 6 in common. 6 goes into 18 twice, 3 times. 6 goes into 12 twice. So, and if we think about it here, that 6 is the same as this 2 times 3 that we canceled out. So another way of thinking about it, you may not understand it yet. I'm just giving you the background so that when you look back on these videos later, you'll understand it. So those are factor trees. I'll make a video about least common multiples and greatest common factors, which will use our factor trees a little bit more. Okay, bye.